we start off with the questions. We have a first question. Two reactions are given and we have to find the role of H2O2 in it. So the first reaction is H2O2 plus O3 gives H2O plus 2O2, and the second one is H2O2 plus Ag2O gives 2Ag plus H2O plus O2.
Yeah, what is happening in these reactions? First one, H2O plus O3 will be reacting to give H2 and O2. Okay, and second one, H2O2 and Ag2 will give Ag and O2. In this, we can see that Ag is directly reduced from Ag2O to Ag, and in this reaction, O3 is converted into O2. This is neither an oxidation nor a reduction. Okay, here what is happening that H2O2 this is in minus, hydrogen is in +1, and here it is also in +1.
Okay.
So nothing with that, but in O2 we can see that it is in -1. Okay, and it is going into -2 here and 0 here. So we can see that oxygen is going in a disproportionation reaction. Okay, and in the second reaction, the Ag2O is reducing to Ag. Okay, so we can see that role of H2O2 is to reduce the other compounds. So the answer will be this one.
Okay, so third one, as we saw, because in both the process there is reduction occurring, and the third one is the correct answer. Now we move over to question number 2. It states that hydrogen sulfide is acidic while water is neutral, and what is the reason for it, and where the options are given. First one is that molecular weight of H2S is more than water. Second, water molecules associate while H2S molecules do not. Third one is HS bond is weaker than HO bond due to bigger size of S atom, sulfur atom. And the fourth is sulfur atom has less affinity for hydrogen atom than O atom. So Deepak will tell us.
Yeah, in this question we said that first one is molecular weight of H2S is more than water. This is true, but molecular weight has nothing to do with the acidity. Okay, so we cannot conclude anything from this. So the second one is water molecule associates with H2S, molecules do not. Okay, but this also had nothing to do with the acidity. Okay. Third one is HS bond is weaker than HO bond due to bigger size of sulfur atom. In this we can see that HS and HO. If this bond is weaker, then it will readily produce H plus and S minus. Okay. And the what is acidity is the tendency to produce H plus ions. So this bond is weaker, then it will readily produce, easily produce H plus ion, so it is more acidic. Okay, so this will cause more acidic nature of H2S than H2O.
We have question number 3. Which of the following is non-reducing? H2S, H2DE, H2SE or H2O?
Let me tell you that the reducing nature increases down the group. That is, increasing nature will be in the order like H2TE, then it will be H2SE, then it will be H2S, and then it will be H2O. So hence H2O is the least reducing agent, or actually it is neutral, so it is non-reducing agent, except that all of these are reducing agent.
Okay.
So answer is H2O.
Now we get to the fourth question. Which of the following processes will produce hard water? First, saturation of water with calcium carbonate. Second, saturation of water with magnesium carbonate. Third, saturation of water with calcium sulfate. Or fourth, addition of NaSO4 or sodium sulfate to water.
Okay, so saturation of water with CaCO3. This will cause H2O plus CaCO3.
Okay, CaCO3, right?
Yeah,
Okay.
this will force to produce H2. When this will produce H2S, first it will produce H2SO4, then calcium ions and some H plus ions. Now this will react with the impurities.
So Deepak, where does that sulfur come from? Sulfur atom.
Oh, sorry. This will be CO3.
Okay. That is H2.
Let me correct. H2CO3. Actually, yeah.
Okay, so basically here we saw that we committed a very silly mistake. We should be careful of that. Now, so tell me, like, how does the reaction tell us about hard water, or how much hard water will be produced?
Actually, this was a trap. I have just write down this reaction, but it won't be there. Actually, this is the silly mistake most of the students do. When they are asked that saturation of water with CaCO3,
okay,
they write down this reaction.
Okay.
But this reaction won't happen because CaCO3 is insoluble in water, and it will remain as a precipitate.
Okay. So this was a very interesting point to note, and
this
you also wrote down the reaction.
This reaction won't happen.
To tell us how the train of thought goes and what all happens. So basically, we should refrain from following such a train of thought that the reaction would occur if we are just given the compounds. We should first develop a habit of seeing whether a particular reaction can occur or not, and then we should delve into the details.
Yeah, the first one and second one are the same, as both of the compounds are insoluble in water. Third one is CaSO4 and fourth one is NaSO4. Now, from the definition of hard water, the hardness of water is not because of sodium source of sulfate. So the hardness of water will be because of CaSO4.
Now we have a fifth question. What volume of 20 volume H2O2 required to get 5000 centimeter cube of oxygen at STP?
Okay, 20 volume H2O2 means that one volume of H2O2 will produce 20 volume of oxygen. That means that 1 ml of H2O2 will produce 20 ml of oxygen, and to produce 5000 centimeter cube, we will need, let us say, x centimeter cube of this. So when we see that we can see that 1 volume of O2 will be produced by 1 by 20 volume of H2O2.
Okay.
So 5000 will be produced by 1 by 20 into 5000. So this will be volume of H2O2. This comes out to be 250 centimeter cube. This is how we can calculate the volume of H2O2.
Now we get to the sixth question. What is the correct order of bond length in O2, H2O2 and O3?
To explain the bond length in O2, H2O2 and O3, let us see the chemical structure of these compounds. H2O2, its structure is like as. Second one is ozone. And it remains in a resonating form, that is like this. Okay, and the third one will be O2. From here we can see that between two oxygen atoms there is only a single bond. Here is a partial double bond, and here is a complete double bond. Okay, so we know that a double bond have a more bond order and less bond length. Okay, so the bond length of O2 will be least and bond length of a single bond will be highest. Okay, and this is a partial double bond. So order of bond length will be this.
Yes.
Okay, so the answer will be this 3.
Okay, so basically, yes, we were asked bond length, and we can see in this through this question how important the structures are. So some compound we should always know the structure of. Let's move on to the next question. An inorganic substance liberated O2 when heated turns an acid solution of Ki brown and reduces acidified KMnO4. What is the substance?
As you have just read that the compound H2O2, we have not studied about this compound yet, but we now at this stage we know that this H2O2 liberates O2 when heated. The reaction was H2O2 will produce H2O
plus O2
plus half O2 and it is an oxidizing agent and it will reduce I minus, that is Ki plus H2O2, and it will reduce it to produce I2 and H2O. And third one is it reduces acidified KMnO4. And now we know that the reaction KMnO4 plus H2O2 will produce Mn2 plus. So we know that H2O2 will react with all these 3 compounds, that is all these 3 reactions take place. The answer will be H2O2.
Okay, so here we have our answer. Which of the following is correct? First, hydrogen has same ionization potential as alkali metals. Second, hydrogen has same electronegativity as halogens. Third, it has oxidation number of +1 and -1. Or fourth one, all are true.
Okay. In the first one, the ionization potential of alkali metals. Now we have already studied that hydrogen has ionization potential almost equal to that of halogens, not of alkali metals. Okay, so this one is wrong. The second one is halogen has a same electronegativity as halogens.
Hydrogen has the same electronegativity as halogens.
Hydrogen, sorry. So we know that hydrogen has electronegativity about 2.1.
Okay.
And of halogens it is more about 3. More than 3. So it is also incorrect.
Okay.
And it has a oxidation number of +1 and -1. Now we have seen that in some most of the compound it has oxidation state as +1, and also in some compound it has -1, like
in hydrides.
Like hydrides of active metals. Okay, so this one is right. So this one is not correct also. So the answer will be 3.
Okay. So it is the correct answer. So now we move on to the 9th question, which is what is the oxidation state of oxygen and hydrogen atoms in H2O2?
Okay. To understand the oxidation state of hydrogen and oxygen in H2O2, let's see the structure. Now from here we can see that hydrogen is connected to O, so it will be in +1, and this will also be in +1. And since oxygen atoms are connected, there will be no charge because of this bond. Okay. So if here is +1, then here it will be -1, and here it will be -1. So the oxidation state will be +1 and -1. Here the mistakes all of the students do is that they think that oxygen is always in -2 oxidation state, and so when they see this type of question, suddenly takes the answer like this. But this is not correct. You have to first write down the structure, then you can decide what is happening. Okay.
So let's move on to question number 10. What is the correct increasing order of acidity of CO2, H2O and H2O2?
Yeah. to calculate the increasing order of acidity, let me tell you a new concept, that is acidic strength. Acidic strength is directly proportional to oxidation state of central atom. Oxidation state of central atom, that is in these three compounds, that is CO2 it is C, and H2O2 is O, and H2O it is also O.
Okay.
Now we see that in H2O2 oxidation state is -1,
Okay.
here it is -2, and here it is +4.
Okay.
Okay, so the oxidation is, as we have discussed, that acidity is directly proportional to oxidation state.
Yes.
So it will be like as this.
Okay.
Okay, this is CO2. So the
Okay. So
we get the answer CO2, H2O2 and H2O.
The first option, I think.
CO2,
H2O2 and H2O.
H2O, yeah, this is the first option.
So now we get to the last question. Here are a few statements which are given which are either true or false, and we have to explain them whether they are true or false.
Okay.
First one is hydrogen peroxide has only one replaceable hydrogen. Is that true?
No, it's not true. It is false actually.
Okay, and
Yes,
why
let
is that
me tell
so?
you an answer. Okay, it has two replaceable hydrogens because as the structure of it is like this, and both of these hydrogens can be removed to make a ion like this. Okay. So we can have a salt like Na2O2.
Okay.
So both of these hydrogens are replaceable.
Okay, then second one is H2O2 has higher boiling point than water.
Yeah, it is true.
Okay.
Let me tell you why. Because boiling point, I have already discussed, boiling point is directly proportional to mass.
Okay.
Okay, and in H2O2 there is one more oxygen atom, that is its molecular mass is higher than H2O, so it's higher boiling point.
Okay, so and the last one here, we have this last question with us. H2O2 has stronger dipole interaction than water.
No, it is also false.
That is false.
False, because for it we can again see the structure, and this is H2O. We can see that here the partial charge on oxygen is -2 and here it is -1.
Okay.
That is, and hydrogen it is +1. So the dipole interaction will be in between oxygen and hydrogen here, like it H, O, and H.
Okay.
And so there is less difference in charge, and there will be less interaction, dipole interaction, and here it is more difference, that is -2 and +1. It will be more dipole interaction.
Okay.
It is false. Okay, so the conclusion is that for most of the question, if you want to tell any property, you have to first write down the structure of those compounds, then see the like oxidation state and other properties, and then you can tell the explain other properties.
Okay, so guys, here we saw the theory of hydrogen, basically all the properties, all the compounds related to it, and the concepts of oxidation and reduction along with that. And then we saw how those concepts apply to various questions. So practice well, practice all the questions properly, memorize the theory, and wish you all the best.